continue our last chapter, chapter 11. This is the last chapter of our pre-calculus. Chapter 11, sequence and series. This one is arithmetic sequence. Arithmetic sequence is in the form of a sub n. A sub n is the n term equal a sub 1. A sub 1 is the first term plus n is the n term minus 1 quantity times d. D is the common difference. For example, if I have this arithmetic sequence 8, 10, 12, 14, the common difference here is 2 because 10 minus 8 is 2, 12 minus 10 is 2, 14 minus 12 is also 2. If you want to guess, the next term should be 16, 18, and so on. Now they want you to find the sum of the first 40 terms. So we're going to use this formula here. So we know n is going to be 40. My a sub 1 here is going to be 8. But we don't know a sub n. So I have to go back to the first formula to find my a sub n. Once I have my a sub n, I can plug it in here and find the sum of the first 40 term. So let's look at this example and find a sub n. So my a sub n would equal to a sub 1, which is 8, plus n is 40, minus 1, and my d is 2. Alright, my d is 2. Now we can solve this. So a sub n would be 8 plus 39 times 2. Right? If you do this, you should get 86. This is my a sub n. But they didn't ask for a sub n, they asked for the sum of the first 40 terms. So we're going to use this formula. So s sub 40 would be, my n is 40, a sub 1, a sub 1 is 8, a sub n, I just did it here, 86 over 2. Alright, so if you calculate this, it's going to be 1,880. Right? Now let's look at my second example. They want you to find the sum of 2, 4, 6, so on, all the way to 102. So we're not gonna add all of them and find the answer. We're gonna use arithmetic sequence. We know the common difference is 2. Because 4 minus 2 is 2, 6 minus 4 is 2, and so on. So D is 2, and A sub 1 is 2. Alright? Now the sum. So we have this formula. We don't know what is n. We don't know what is n. Alright, so what we're going to do, we're going to use the first formula to calculate for the n because we have a sub 1 and we have d. So we can use this to find a sub n. So the formula is a sub n is equal to a sub 1 plus n minus 1 times d. Okay. My a sub n here is 104. 102. 102. My a sub 1 is 2. I don't know what my n is, but I know my d is 2. Alright, so we're going to solve here. 102 is equal to 2 plus 2n minus 2. So 2n would equal to 102. N would be 51. Alright, we need to find the sum. So we're going to go back to the formula here. So S sub n is going to be n, which is 51. A sub 1, which is 2, plus A sub n, which is 1 or 2 divided by 2. Alright, if you calculate this, it's going to be 2,652. Alright, let's look at the next example. They want you to find the d and the nth term a sub n of arithmetic sequence. They tell you it's arithmetic sequence. Given the third term is 15 and the 21st term is 87. So we don't know the first term, we don't know the second term, we know the third term is 15 and it's keep on going, right? And the 21st term is 87, somewhere here, right? And they want you to find a sub n, the general term. So we need to know a sub 1. We don't know a sub 1. We need to know the d. We don't know the common difference. All right, so we want to see 21 term and 3 terms is 18 terms between them. It's 18 terms between them. And then we have the 21 term, the number is 87. And the third term, the number is 15. So the difference between the 21st term and third term is 72, but we have 18 terms. So I'm going to find d. d should be 72 divided by 18, which is 4. Alright, now we have the d. Alright, what else do we need? We need to find a sub 1. Alright, so we know a sub 3 is 15, so a sub 2 should be 15 minus 4, which is 11. So 11 here. Alright, we need to find a sub 1. So a sub 1 should be 11 minus 4, which is 7. So 7 is here. Alright, now I'm going to plug it in. A sub n is equal to a sub 1. I got 7 plus n minus 1 times d. My d is 4. So a sub n is 7 plus 4n minus 4. So a sub n is 4n plus 3. Alright, so let's continue to see our geometric sequence. This is a geometric sequence. So the general term is a sub n equal to a sub 1, which is the first term, r n to the minus 1. R to the n minus 1. R is the common ratio. So it's the ratio between the one after and the one before, which is to stay the same. And n has to be greater than or equal to 1. Now, for the finite geometric sequence, the sum is this formula, and r cannot be 1, because if r equal to 1, denominator would be 0, it would be undefined. For infinite geometric sequence, absolute value of r should be less than 1. So let's look at an example here. They give you the condition of a sub 1 equal to 5 and the common ratio is 2. If a sub 1 is 5, common ratio is 2, the next one will be 10 and the next one will be 20 and so on. They want you to find a sub 7, but we're not going to keep multiply by 2 to get a sub 7. We're going to use the formula. So the formula is right here, right? So a sub n in our case is a sub 7 would equal to a sub 1. My a sub 1 is 5. R is common ratio. which is 2, n is 7 minus 1, and n is greater than or equal to 1, when n is 7. So my a sub 7 would be 5 times 2 to the 6, which is 320. Alright, now let's look at the next one. They want you to find the sum of 1/3 plus 1/9 and so on. And this is geometric sequence. Again, if keep on going, but as you can see, the number is smaller and smaller. So it's infinite. So we're going to use this formula. This formula, you have a sub 1, which is 1/3, but we don't have r yet. And you can see absolute value of r should be less than 1. So the common ratio here, you can do 1/9 or divide by 1/3, or 1/27 divided by 1/9. So let's do 1/9 divided by 1/3, right? Just to get your r. So that is 1/9 times 3/1, which is 1/3. So your r is 1/3, which is absolute value of 1/3 is less than 1. So we can use the formula here. So s would equal to a sub 1, which is 1/3, over 1 minus 1/3. So I'm going to have 1/3. 1 minus 1/3 is 2/3, which means 1/3 divided by 2/3. Another word is 1/3 times 3/2, which is 1/2. So the sum of this is going to be 1/2. All right. Now let's look at the next one. They give you a sub n. We don't know what n is, but a sub n is 512, and this is the sequence. So they want you to find the n, and they tell you that this is geometric sequence. All right. So let's find r first. We want to find the n. So they didn't ask for the sum, so we're not going to worry about these two formula. They want you to find the n, so we want to find n. Let's find the r. R is common difference. So I can do 4 divided by 2 or 8 divided by 4, doesn't matter. You should get the same answer. So 8/4 is 2. And 2 is greater than or equal to 1. Alright, so now I'm going to plug it in this formula to solve for my n. A sub n, my a sub n is 512. Alright, is equal a sub 1. A sub 1 is 2. This one, a sub 1 is 2. R, we just did r here, is 2 to the n minus 1. Alright. Now I have to solve for 2. So what I'm going to do is I'm going to divide both sides by 2. So I'm going to have 256, 2 to the n minus 1. Alright. Now you have to solve for n. One way of doing this is you try to make the base the same. This is base 2, make this base 2. If you can, you have to take log and do all that. I think 2 to the 8. 2 to the 8 is equal to 256. Alright? And then on the right hand side, I have 2 to the n minus 1, which means n minus 1 equal to 8. Then n would be 9. So my n is 9. Alright, see you next time.